Today I'm going to be talking about solving the quadratic equations by completing the square. This is a day 1 for chapter 4, section 3. So before we talk about completing the square, I'm going to talk about solving an equation using square roots. So we need to be able to identify a perfect square trinomial. So for number 1, if we look at this, it's r squared minus 10r plus 25. This is a perfect square trinomial. So what we can do is we can rewrite this perfect square trinomial as the square of a binomial, which is going to be r minus 5 squared equals 1. Because negative 5 times negative 5 is a positive 25, and negative 5 plus negative 5 is a negative 10. So being able to recognize that perfect square trinomial and being able to rewrite it as the square of a binomial is going to be the biggest piece of completing the square. Now that we've rewritten it like this, we've solved problems like this before using square roots. So what we can do is we can square root both sides. Don't forget to do plus or minus. So we now have r minus 5 equals plus or minus 1. Okay, now we have to add the 5 to both sides. And now we simplify. R is going to be equal to 4 and 6. And that is our answer. So if we look at number 2, once again, we have to recognize our perfect square trinomial. M squared plus 8m plus 16 is a perfect square trinomial, and that can be rewritten as m plus 4 squared equals 45. 4 times 4 is 16. 4 plus 4 is 8. Now that we've rewritten this, we can square root both sides. So we have m plus 4 equals plus or minus the square root of 45. We still need to simplify our radical. So we have m plus 4. Let's do this over here. M plus 4 is going to equal plus or minus So we now have m plus 4 equals plus or minus 3 square roots of 5, because 45 is 9 times 5. Then we're going to subtract the 4, so we have m equals a negative 4 plus or minus 3 square roots of 5. And we have our answer. Okay, so being able to recognize that perfect square trinomial. All right, up next it says solve the equation. Oh, there's more examples of solving the equation using square roots. Okay, so if we look at number 1, we have x squared minus 26x plus 169. Once again, this is a perfect square trinomial. We can rewrite this as x minus 13 equals a negative 13. Okay, and negative 13 times negative 13 is 169. Negative 13 plus negative 13 is negative 26. We can square root both sides. We do have a negative underneath that radical, but that means we can pull out an I. So we have x minus 13 is equal to plus or minus I square roots of 13. So now we have x equals 13 plus or minus I square roots of 13. So we no longer have that no solution. We can use imaginary numbers to solve this one. Okay. Up next for number 2, we have 4x squared minus 8x plus 4. Now what we can actually do to make this a little bit simpler is we can divide by 4. We are going to get a fraction, but that's okay. Let's divide everything by 4. So we now get x squared minus 2x plus 1 equals 1/4. Now this is a much easier perfect square trinomial. We can rewrite this as x minus 1 squared equals 1/4. Now we can square root both sides. Plus or minus, so we now have x minus 1 equals plus or minus 1/2. Okay, because square root of 1 is 1, square root of 4 is 2. So we now have x equals 1 plus or minus 1/2, and we can simplify that as x is equal to 1/2 or 3/2. There we go for that one. All right, now we're going to actually complete the square. So that means we're rewriting a trinomial to make it into a perfect square trinomial. So it says find the value of c that makes the expression a perfect square trinomial. Then write the expression as the square of a binomial. So this is kind of what we've been doing before, but now we have to figure out what c is. Now there's a way to do this. There's a formula for completing the square, and that's b over 2 squared. That's going to help us find the value of c. So in this case, our b is 20. So we can do 20 divided by 2 squared, which is 10 squared, which is 100. So it's our c value is going to be 100, and our our square of a binomial is going to be x plus 10 squared. And my trick is that inside of this parentheses is what goes right here, kind of a shortcut. So we have our x plus 10 squared. That is completing the square. So let's try that again. This one, the b value is negative 22. So negative 22 divided by 2 squared, we get a negative 11 squared, and we get 121. So our c value is 121. So our perfect square trinomial is t squared minus 22t plus 121. And to rewrite this is t minus 11 squared, and that is our square of a binomial. So that essentially is completing the square. Finding that c value is completing the square. Okay, so let's try a couple more of these. Our 24 is our b value. So we're going to do 24 over 2 squared, which equals 12 squared, which is 144. We rewrite this as x squared plus 24x plus 144. And our square of a binomial is x plus 12 squared. Our last one, we have a negative 26 as our b value. Divide that by 2. We get a negative 13 squared, which is a 169. So this is going to be s squared minus 26s plus 169. We rewrite that as x minus 13 squared. And that hint of using that number inside of the parentheses really does speed things up. All right, so now what we're going to do is we're going to put all these pieces together and we're going to solve the equation by completing the square. Okay, so the first thing that we need to do is we need to have the a and the b isolated. So we're going to have to move our c over, which that negative 6, we're going to have to move it over. So we're going to rewrite this as s squared plus 2s, and I leave a little bit of room, equals 6, because we add the 6 to the other side. And you'll see why I leave some room for this one. So now that we have the a and b isolated, and we have to make sure that the leading coefficient is 1. If the leading coefficient isn't 1, we can't complete the square. But this one it is. So now we're ready to complete the square, and our b value is 2. So we're going to have 2 divided by 2 squared, which is 1 squared, equals 1. Okay, so what we're going to do is we're going to rewrite this as x squared plus 2s plus 1. That's our c value. But what we do to one side, we have to do to the other side. So we also have to add the 1 on the other side. That's the biggest part. If we don't add 1 to the other side, it's not going to equal out. So now what we can do is we can rewrite this perfect square trinomial that we've made into the square of a binomial, which is s plus 1 squared equals 7. Okay, now we've made it so where we can use square rooting. So now we can square root both sides. Don't forget to put plus minus. So we now have s plus 1 equals plus or minus the square root of 7. S will equal negative 1 plus or minus the square root of 7. So that is completing your square. You find your c value, you add it to both sides, rewrite your perfect square trinomial as the square of a binomial, then square root. Okay, let's try it for number 2. We have to isolate our a and our b. Our leading coefficient is 1, so we don't have to do anything. So we have t squared minus 8t equals 5. Negative 8 is our b value. So So we have a negative 8 divided by 2 squared gives us a negative 4 squared, which gives us a 16. So what we're going to do is we're going to add 16 on both sides. Don't forget the right side. Okay, now we're going to rewrite our perfect square trinomial as a square of a binomial. So we now have t minus 4 squared equals 21. Now we're going to square root both sides. So we have t minus 4 equals plus or minus the square root of 21. T equals, move the 4 over, 4 plus or minus the square root of 21. And now we've got that. So that's your completing the square. Let's practice a couple more of these. All right, okay. So now if we look at number 1, first of all, we have to isolate the a and the b, and also our leading coefficient is not 1. So to get our leading coefficient to be 1, I'm going to divide by 6 first. Divide everything by 6. So we now have r squared plus r plus 2 equals 0, but we still need the a and the b to be by itself. So now we have r squared plus r equals a negative 2. Okay, so we have to make sure our leading coefficient is 1 and our a and a b are isolated. Okay, now our b value for this time is 1, so we do 1 divided by 2 squared, which gives us 1/4. So now we're going to add 1/4 to both sides. Okay, we can rewrite this as r plus 1/2 squared equals a negative 8/4 plus 1/4, because we got to add those together. So now let's simplify, and we get r plus 1/2 equals a negative 7/4. Okay, we do have a negative, but that's okay because we can use our imaginary numbers. Now we can square root both sides. So we now have r plus 1/2 equals plus or minus I square roots of 7 over 2. Okay, because the square root of negative 7 is I square roots of 7, and the square root of 4 is 2. Now we move our 2 over. R will equal negative 1/2 plus or minus I square roots of 7 over 2. Since we have the same denominator, we can combine. So we have a negative 1 plus or minus I square roots of 7 all over 2. And that is in our simplest form. Okay? Let's do the next one. Now, if you notice, this is not in standard form. So the first thing we have to do is we have to distribute. So we're going to get 4w squared minus 12 equals 24. Now our a and our b are isolated, but our leading coefficient is not 1. So we're going to have to divide everything by 4. So we now have w squared minus 3, I'm going to leave a little bit of a space, equals 6. Okay? Wait, that should be w right there. There we go. Okay. Now our x value is a negative 3, so we're going to complete the square. So it's going to be a negative 3/2 squared, which gives us a 9/4. So we're going to add 9/4 to both sides. Okay. So we're going to rewrite this as w minus 3/2 squared equals 24/4 plus 9/4. So now we have w minus 3/2 squared equals 33/4. Okay. Now what we can do is we can square root both sides. Plus or minus. Let's bring that over here. So we now have w minus 3/2 equals plus or minus the square root of 33 all over 2. Okay, now we're going to add our 3/2. So w equals 3/2 plus or minus the square root of 33 over 2. We have the same denominator, so now we can combine. So our final answer for w is 3 plus or minus the square root of 33 all over 2. and that is completing the square.